high level discussion, and later on we will have another tech talk like that. In that we can go with some technical implementations, but right now first for this first tech talk today is a high level discussions. So just a second. Okay, so yeah. So before going to the understand microservice, like we are going to understand like why are microservice used. So microservice were used to overcome the challenges. So maybe you are aware about when we are working with that legacy monolithic architecture, there was a big box, and in the big box we are working with the we are working as a small piece of that huge box, right? So we had a too much teams, we are working in the one box, and it is a very cumbersome and very complex to manage the code, to introduce the new features and so on. So we are going to understand like that, like what microservices were used to overcome the challenges of monolithic architecture that prevail initially in the market, and also enables you to deploy independent services. So as I told you, like before that microservice, it was a huge box. It's called a monolithic application. So what happened in monolithic application? So monolithic application itself contain everything. For example, communication. For example, code, front end, back end, everything would be covered in a single box. Okay. So it was very hard to work with that box. Like for example, I'm working in the monolith application and I want to deploy something for specific to my changes. Then it would be very hard to deploy on the any environment, because other team also working on the same box, and you are not aware about like what they are working on, what is the impact of their work and so on. So it's a very hard to deploy the single box without everyone consent. Second, like so before we move on, what is microservice in simple word? Let's see the architecture that prevail initially in the market. That is monolithic architecture, and in layman terms, you can say that it's a similar to big container wherein all the software component of an applications are assembled together and tightly packaged. So as I told you, like it is a one box, so it contains everything. So the main dependency, there are the list of the challenges which we have faced while we are working with that monolithic applications. So it's called inflexible. So monolithic applications cannot be built using different technologies. That is the biggest disadvantage. So when we are working with the monolithic application, you cannot avail any new technology feature or any different technology benefit in your application. If you are working with the Java, if you are working with the .NET, if you are working with the Node, that whole monolithic application contains only the single technology. You cannot mix up the technologies in the monolithic applications. Then there is unreliable. Even if one feature on the system does not work, then the entire system does not work. So there's the second biggest problem in the monolithic applications. For example, we have a huge box which contains different modules like login, sales, purchase, and reporting, so on. So when we have facing one issue, for example, if you have a purchase module, the purchase module have a problem regarding something like out of memory issues. Okay, so when one module has a problem, the whole application would be down. So you cannot control to work to keep it up a single modules. So this is the biggest disadvantage of monolithic application. Then the third one is like a unscalable. Application cannot be scaled easily, since each time the application needs to be updated, the complete system has to be rebuilt. So as we all know, when we are working with the monolithic applications, we have to deploy everything on a one server. Okay. So when for example, we already working with one server, and later on in the future, our traffic has been increased and we have to increase the servers. We have to like survive the load, increased load. So at that time it is very difficult to scale, because you have to maintain each and every configuration which is done on the one server has to be done on the second server. If you missed out any single cheese, any single thing, then your application server would be down. It will not comes up until your both servers be identical. So this is the problems in the monolithic application scalability. Second, like when what happened when your traffic has been increased, somehow you figure it out to start a new server, and your traffic will be divided into servers. Later on, your traffic more increase in the some season, you will add one more servers. But what is the problem? When your traffic has been decreased, you have to manually remove that servers. Okay, at that time. So it was the problem. So now over here you bearing the cost, because when you are proper like spawning a server, it will cost you server maintenance, server memory, computation, everything would be costable, right? There is no free. So when you add a new server, it will start more cost. But when your load has been decreased, you have to manually downgrade the servers. Then there's a blocks continuous development. So what happened in the monolithic, as I told, like there are multiple teams working on a single project. Okay, so one team has done some feature and they have to release their feature in the production, but the problem is they cannot release because there's another teams are already working on, they have to release their features. So each and everything would be dependent, so you cannot like release any half build feature, or some teams is already working and some work is not done and you are going to deploy on the production. No, you can't. So it is blocks you until all the development cycle has been done by all the teams. Then slow development. So this is the main disadvantage. Again, we can say the development will be slow because in the development in monolithic application take lot of time to be built, since each and every feature has to be built one after the other. So for example, there is a one box and you are developing one feature, another team is developing second feature, which is depends on. So you cannot just like start your working until the first feature is done, right? So this is the dependency, you can, it will slow down your development. So in microservices you could not, both services are different, you both are working together parallelly. And the last one is not fit for complex applications. So features of complex applications have tightly coupled dependencies. So now what happens when you have to design some complex features in the monolithic application, it is very hard to fit that new feature in the existing box. Okay, because when you are touching the existing code base, may or may not it will break your functionalities. When you deploy in the production, you realize something like, oh, this is the functionality which is broken down due to this implementations. So this is a very, these are the very disadvantages, list of disadvantages of the monolithic applications. So let's move to the next one. uh, what exactly is a microservice? So what is microservice? So microservice basically dividing your huge problem in the small business applications or business domain. For example, let me give you one example. Like you have a HR system. So in the HR system, you have a logging, you have a leave management, you have a pay scale management, you have a resource management, you have a like the dashboard kind of thing. So okay, so this all are, if it is in the monolithic application, the whole box would be a single one, but in the microservice you can divide such modules in the small microservice. For example, you can see in this image like microservice 1 2 3 4 and n. So it is, you can design your microservice based on your business domain. So whatever your business domain, you can separate it out, that business domain, you can design the microservice on top of that. So what is exactly microservice? So microservice is an architectural style that structure an application as a collection of small autonomous services modeled around a business domain. As I told, like you can divide your huge problem into small solutions, like leave management is a separate module, logging management is a separate module, auditing is a separate module. So if it could be not affect your existing microservice, for example, your one microservice has a problem, your other microservice will be working fine. So for example, when you are working with the HR system, your leave management is not working, then it will not impact your pay scale management and resource management like that. You will be serve your other resources with the pay scale management or resource management and so on. But if it is in the monolithic application, when your leave management is down, you cannot serve other modules too. Then in the given the given architecture itself, as I told you, it's dividing huge monolithic applications in the small microservices. So difference between traditional architecture and microservice. So you can see there is two images. One is the first one. The first image, it says client browser, and all the customer service, product service, card service, all will be remain in this one box. And for example, when you have to work with the product services, you have to think about the card service, and customer service will not impact by your new development or new feature enhancement. In the second hand, in the microservices, you can see the client browser is separate out, same as the monolithic, but there's a UI, separate UI for the microservices. Okay, and UI will be communicate with each microservice as a separately. Like you can see customer microservice, product microservice, cart microservice, and even in the backend, customer microservice can communicate with the cart microservice, product microservice via different ways. Okay, I will tell you like how many ways we can communicate with microservice. So we can see in this context, like text, the main difference was observed in the above diagram is that all the features initially were under a single instance sharing a single database, but then with microservices, each feature was allotted a different microservice handling their own data and performing different functionalities. Then architecture of microservice. So you can see the image, like there are multiple clients like a mobile, web, cloud, APIs, iPhone, iOS, whatever it is. Then there are management capabilities over there who can manage the controls over the microservice communications. And you can see the inner infrastructure. So inner infrastructure contains the microservice A, B, C, D. So these all microservices would be communicated via API gateway. You can see that management capabilities over there. We can see API gateway. So any client want to communicate with any microservice, they have to reach the API gateway first, and it's API gateway responsibility to divide their request to a specific microservice based on the configurations. Okay, and you can see at the bottom the communication channel. It could be a message bus or HTTP REST. So as I told you first, like communication, there is a communication way where microservice A doing with microservice B, C, and D. So it's called inter-service communications. So inter-service communications can be done via HTTP and via messaging brokers. So HTTP, when you are communicating, it is called a blocking IO operations, and when you are using the messaging bus, it is like asynchronous communication. So you just fire and forget like that. So as we see the text architecture of microservice, so different client from different devices try to use different services like search, build, configure, and other management capabilities. So there is no restriction like you can communicate only this way. There is a different clients, they can communicate with that. Okay, in the monolithic it is not feasible. Okay, we have to when we have to expose some API, we have to provide some another authentication mechanism or whatever to the third party to communicate with our APIs. In the then second one is all the services are separated based on their domain and functionalities and are further allotted to individual microservices. So as I told you, when you are designing the microservice, there is a two way to design the microservice. One way you can like share the database and manage the transaction via two-phase commit or whatever like Saga implementations. But second way, we can have that microservice would be designed on the domain specific. So when we are designing the domain specific microservice, the data would be the database is same single for that microservice. A has its own database, microservice B has its own database, and so on. So all the services are separated based on their domains and functionalities and are further allotted to individual microservices. Now the third one is like these microservices have their own load balancer and execution environment to execute their functionalities and at the same time capture data in their own databases. So now this is the most important part. Like when we are talking about the microservice communications, so it says these microservices have their own load balancers. So when we are working with the microservices, microservice itself it's a auto scaling. So when the terms comes auto scaling, you require a load balancer which is used to communicate with that list of microservices under that load balancer. So for example, let me give you one scenario over here. So microservice A and microservice B. So for example, microservice A is doing logging mechanism like managing the logging, user authentication, and microservice B is doing something like leave management. Okay, so when we are working with the microservices, microservice A does not have too much load to serve the client request. So it would be easy, like you can allocate 1 GB RAM and 1 core CPU, which is handled by that microservice A. But in the microservice B, it could be possibilities like you can the one instance could not serve all the load. So you can like scale the instances of microservice like B microservice B have 3 instances. Okay, so at that time you required a load balancer who can divide a load in that 3 microservices. Okay, that's why it says like these microservices have their own load balancers and execution environment. So load balancer, I told you, like when your instance has been scaled out, the load has been divided into the scaled instances. So if it is a 3 number load instances scaled out, then you have to divide your load up to the 3 microservices. And second is the execution environment. So when we are talking about the microservice, you may remain one word like a Docker. Okay, so Docker is nothing but a snapshot of one image which is created from any operating system like Amazon AWS Linux or Ubuntu Linux or whatever the base environment operating system, and on top of that you can run or your microservice in that container. So when we are talking about the microservice, there is a huge instance which is divided in the small containers. When you are configuring your microservice, you will allocate that microservice how much memory and how much CPU will be allocated to this microservice. Okay, and based on that your containers would be created with that configurations. So when your container is running, your microservice B have 3 containers running, so it will not impact each other. So each container has their own execution area. When anything comes down, comes any problem with container 1, it will not impact container 2 and container 3. So all are separate, no one can disturb each other, either it is in the same instance. The working execution area has been separate out. Okay, so uh, and also as I told, like it's a domain specific design. So when we are designing the database, we can allocate one microservice as a one database schema. So you do not have to worry about the transaction management by the shared database, because your microservice communicating with your database. So every time you have to take care about management the transaction from your microservice only. Then fourth one is like all the microservices communicate with each other through a stateless server, which is either REST or message bus. So as I told you, like when we are thinking about architecture, so architecture is not like a small piece of modules, like 2 or 3 modules comes together and you will work and you will serve the purpose of the requirement. It happens, but it happens in the small scale application. But when we are talking about the large scale application, there is a n number of microservice. Okay, so for example, you in one application you consider like you have 50 microservices. Okay, so over here you require communication. So one way of communication, client communicate with the microservice via API gateway only. But second way of communication like intercommunication. So when we are making one microservice call, and that microservice call going to the second microservice. Okay, so over there what happen? You have to communicate internally. You cannot tell customer to go back and coming back from browser to API gateway to second microservice. No, you can't. You have to perform inter-service communication. So inter-service communication has been done via two ways. One is a synchronous way and one is a asynchronous way. Okay, so what is a synchronous way? Synchronous way means we are using the REST template, or if you may aware about Spring Boot, then you can use the Spin client. Okay, so this is the HTTP communication, HTTP or HTTPS communications. So over there, when you make a call to the next microservice, you have to wait until you get back the response. Okay, so over here, this is a one way of communication. This is called synchronous communication. And second way is asynchronous communication. So asynchronous communication done via the messaging broker. So you may heard about JMS very beginning, but nowadays there are multiple messaging brokers in the market like RabbitMQ, Kafka Topics, then a simple queue service by Amazon, then JMS is there, then SNS, and like MQTT. There are multiple messaging brokers available in the market to install in your cluster, and that are responsible to communicate from one microservice to another microservice. So it's purely work on the publisher subscriber concept. So one microservice would be a publisher and second microservice would be a consumer. So when you post any message in the microservice, second microservice would receive that message and process the message and perform whatever business logic you write down. And based on that, they can communicate back to the microservice A, like the operation has been successful or not, via communication as a asynchronous using the messaging broker. Okay, so this is a two-way of communication in microservices. Now microservices know their path of communication with the help of service discovery and perform operational capabilities such as automation monitoring. So this is a very important point over here. For example, I talked about microservice, and there is a huge number of microservices like microservice A, B, C, D, E, F, G, H, I, to up to Z. Okay, so now when we are working with the one single box, we know like on which domain and which IP I have to communicate. Okay, but when we are working with the microservices, the port allocation and IP allocation would be dynamic. You cannot get every time a static IP. So how you will discover your microservice, because your microservice is not like accessible outside of your box, your infrastructure, right? There is only one way of entry point is API gateway. So over there, you required discoveries, microservice discovery. So if you heard about Spring Boot, Spring Boot has a Eureka. So Eureka act as a service registry and discovery. So when you comes up with your microservice, there is a Eureka configurations. You have to provide the endpoint of Eureka where you register your microservice. Hey, I am coming up and I am registering myself as a microservice A in the Eureka registry. So whenever API gateway comes, they just will find the name of the microservice. It does not have to worry about the IP and port. It just look for that name, and based on the registry it will return the actual communication path, like whatever it is, dynamic IP and dynamic port, and it will return to that API gateway and again come back to that actual microservice communication. So this is the main role of Eureka, like a service discovery. Okay, then all the functionalities performed by microservice are communicated to client via API gateway. So as I told you, like when we are designing the microservice architecture, so API gateway is the most important part in the microservice architecture, because you can only communicate, like outer part is only communicate with my infrastructure via API gateway. Okay, so what is the API gateway? API gateway first facing, front facing component for any external communications, or either it is a web, either it is a mobile, either it is a API communication or cloud, whatever it is. The API gateway is a front facing component, and all the requests will be then landed to the API gateway, and it's a API gateway responsibility to get actual microservice name based on the configurations, and the request would be routed to that actual microservice. So if you heard about Spring Boot, Spring Boot have providing one more component like Spring Zul proxy. It is working as a API gateway. Then all the internal points are connected from the API gateway. So anybody who connects to the API gateway automatically gets connected to the complete system. So as I told you, like API gateway is the front facing component. So whenever you communicate with API gateway, you will be communicating with the downstream system, whatever it is, a full infrastructure, microservice A, B, C, D, based on the like configurations, your request would be routed to the microservice. Now API gateway. So the now maybe you are thinking about how, if I'm coming to the API gateway, if I know the URL, the API gateway would be redirected to that microservice and I can access the data. But the main role of API gateway is like routing the request plus authenticating the user. So in the microservice, what happen? There is a separate microservice called authentication management. So API gateway is responsible to communicate first with that authentication service, and authentication service will revert back with that data with response code 200 or 401 or 403. Based on the response code, API gateway would redirect to the actual microservice. So for example, I am a user, I am using this HR management system, I am logging myself. So when I am logging myself, it will first communicate with API gateway, will first communicate with the login management authentication system, and authentication system will authenticate me, like okay, I am Uday Patel and this is my login credential. It will find in the database or LDAP or whatever configurations we have, it will authenticate myself. Then it will generate a token. The token, you may heard about JWT token, JSON Web Token. So it will generate the token, and token generation has the policy, it is a separate concept. So it is generated by the authentication service and revert back to the API gateway. Now API gateway has the responsibility to redirect that request to the front end. So when it's authentication, always it redirect to the front end with that token, and all the subsequent request to that session would be done by that token only. So you have to provide your token in the authentication header. Later on, when the subsequent request comes on the API gateway first redirect that token to the authenticate service. Hey, I received this request, please authenticate this token. Is this token valid or not? Okay, or is this token expired or not? So the authentication microservice will be done the authentication, and based on it will return 200 or 401 or 403. 401 is called unauthenticated and 403 is called forbidden. So if it is a 200, it will redirect on the leave management module, or it will redirect on the resource management module, whatever it is. But if it is a 401 or 403, it will redirect back to the customer without impacting our infrastructure. It direct return back to the customer, says, hey, the token has been expired or the token is not valid, etc., etc. So based on the your need, you can configure the messages. Okay, then microservice features. So as I told you, microservice is designing your huge application in the small pieces. So what are the features we are getting from the microservice? First feature is decoupling. So service within a system are largely decoupled, so the application as a whole can be easily built, altered, and scaled. So as I explained, like when we have a 4 microservices, though these all are decoupled with each other, they could be communicated via REST or via messaging broker. So whenever you have to build something new in the microservice, it will be very easy for you to insert a new functionality in the existing microservice, because when you are adding new functionality in leave management, it will not impact your resource management and pay scale management and all, right? Then you can easily alter and you can scale, as I told you, like one microservice can scale up to 1 to n, and the whole cluster can be scaled. Okay, so when it is not any problem to scale the microservice, you can easily manage this. Then component componentization. So microservices are treated as independent components that can be easily replaced and upgraded. As I told, like all the services are decoupled. Okay, so the you can easily if you want to replace any existing microservices, or if you want to upgrade the any existing microservices from, for example, you have when you started your applications, you provided version v with the rest endpoints. Now you want to provide some more functionalities with change of version v2 of the APIs, then it will be very easy to upgrade and replace the existing microservices. Then business capabilities. So microservices are very simple and focus on a single capability. So as I told, in the microservices, each responsibility has been divided to each microservices, right? You cannot mix up the business domain with two like HR and pay scale management and leave management in a single box. So each has their own focus and capabilities. So you do not have to worry about that mix up of the domains and all. Then autonomy, developers and teams can work independently of each other, thus increasing speed. So as I told, in the monolithic, we had a single box. So when you have to start developing and it is depends on some other things, then you have to wait, or it will slow down your development. Even you have to deploy something, then you have to take a consent from that another team, like, hey, your development is done, I have to deploy this in the development or QA staging or production, whatever it is. But in the microservice, you do not have to worry about, because each microservice has been separated out. You are working with two microservices, so you have to only focus with your two microservices only, and you can easily do development in that microservices. You can easily do deployment on that microservices without impacting other microservices. So it is the advantage. Then continuous delivery, as I told, like allow frequent release of software through systematic automation and software creation, testing, and approval. So in the monolithic application, I told, it is a huge box. You cannot easily deliver the things, right? Because the huge teams are different teams are involved in the development. You have to take a consent. You have to take the approvals from the all the team member team leaders, and you have to take the you have to perform all the regression testing, and all is working good. You have to do the properly before releasing the production, like that. But if it is in the microservice terms, it would be release your all pain. You have to just focus on your microservice. You have to perform only testing on your microservice. Maybe you can write down the integration testing and unit test cases for that microservice, so you do not have to worry about. There is a pipelines which is used to continuous integration and deployment. So when your continuous integration is done, you can configure pipeline which is perform the unit testing, integration testing, and all. And you can add the consent to approval button in the pipeline, like who is the leader who can approve that button, and your deployment would be start in the actual deployment stage. Okay, so this is the continuous delivery we can manage in the microservice. Responsibilities. So microservice do not focus on application as a project. Instead, they treat application as a product for which they are responsible. So as I told, each microservice have their own responsibilities. So it is considering like a small product for your huge infrastructure ecosystem. It is not like a huge project. Okay, so leave management has their own responsibilities. They only care about the leaves. how much leaves has been allocated, how much leaves has been deducted, how much leaves has been applied, and they only responsible to manage the leaves flow. Like when I apply the leave, it will be go to my manager and upper manager and so on. Then decentralized governance, so the focus is on using the right tool for a right job. That means there is no standardized pattern or any technology pattern. Developer have to freedom to choose the best useful tools to solve their problem. So this is the most important point in the microservice architecture. So now before that you may heard like hey, we required only Java people because we have a Java application. Hey, we required only .NET people because we have .NET application. Now after the microservice evolve, like you are not depends on one technology. For example, let me give you one scenario. We have a shopping cart application, okay, or we have a in the shopping cart. So in the shopping cart you are displaying the items, you are uploading the videos related to that items, okay. So over there what happen when we are uh, doing some streaming work, okay, it will block our operations if it is a standard technology IO operations blocking IO. For example, it's not a reactive but Spring Boot, okay. When we download some data, it will block my thread until the file has been downloaded. So I'm talking about shopping cart. In the shopping cart we have a videos which actually describe the product. So when you see the video, it will block your operation. So over there you have a choice. Either you can go with the Spring Boot, either you can go with the Spring Reactive, either you can go with the Node.js. These are the choice you have. So you can mix up the technologies without creating any problem with your existing ecosystem, okay, because your all microservices remain under the your infra. It is not accessible outside the world. Only one facing point is the API gateway. So you do not have to worry about which technology has been used to design which microservice. Either you can design your two microservices in Java, three microservices in Python, five microservices in Node.js, whatever technology is suitable for your use case, okay, and based on that your whole ecosystem has been developed. But when we are talking about monolithic, you cannot get this advantage, and this is the very biggest advantage, because when we are actually working in the ecosystem, huge ecosystem, at that time there are multiple things comes in the picture, like licensing cost, storage cost, then computation cost, memory cost, instances cost, clustering cost. So there are multiple cost comes in the picture, okay, and the cost would be depends on the technologies, okay. So you can choose whatever is easy for you and whatever is cheaper for you, and you can get this advantage only in the microservices. Then agility, so any new features can be quick developed and discarded again. So as I told, like microservice is a simple separate component. So whatever features you want to add, you can add it, and you want to discard, you can discard it without impacting your ecosystem, okay. You can add the feature, you can deprecate the feature, you can discard the feature based on the small configurations in the application.yml or application.property, whatever, or you can use the feature flag, whatever you can want. But it is very easy to add and discard the any features in the microservices. Then advantages of microservice, so independent development. All microservices can be easily developed based on their individual functionalities. So as I told, like HR ecosystem has a leave, resource management, pay scale management, all. So all microservices can be easily developed. So each microservice is separated out, so you do not have to worry about the other functionalities. You just focus on your functionalities. Okay, you can just evolve your functionalities and develop it. You do not have to worry about, hey, I'm going to change this DTO or this DAO will be impact in the other module. No, you do not. Because it's a completely isolated box for you. You can change whatever you want in your microservice. It will never impact to the other microservice until you have the shared classes or shared libraries. Okay. Then independent deployment. So based on their services, they can be individually deployed in any applications. So as I told, like each microservice has their CICD. So whenever you commit, you can configure your hooks, and when you do commit, your hooks will be called and it will start your building and deployment using the CICD like Jenkins and GitLab. So it is separate. When you deploying your Psql microservice, you do not have to worry about your leave management and resource management and login management, auditing. It's fine. It is only focused on your microservices. Then fault isolations, even if one service of the application does not work, the system will continues to functions. So this is, as I told, this also, like in your huge ecosystem, if it is a single box, then it would be always a problem when your one module is down. For example, where your one module is taking too much memory and you will receive out of memory. So your one module is down, your whole echo is down. But when you are looking about the microservices, you have one microservices down, you do not have to worry about other microservices. Other microservices will be there. It will work as expected. Then mixed technology stack, different language and technologies can be used to build different services of the same application. So as I told you, same things like you can achieve mixed technology stack over here. You can use Java, Python, Node.js, then any scripting language in the backend. You can use Django framework. You can use .NET with mix up of Java, whatever you want, because it's a free to use any technology to design your microservice. Okay, because everything would be in the one infra and everything would be communicated via on the API gateway. Then granular scaling. So individual component can scale as per need. There is no need to scale all component together. So this is the also very good point. Like in the monolithic application, we have three modules. For example, leave management, resource management and pay scale management. So at the end of the month, your pay scale module will be very high usage. Okay. So due to that, you are getting some out of memory or whatever in the instance, you have to increase your another instance. So due to one module, you have to increase the instance. So this is the not good way, because other modules are there. They are not consuming any memory. They are not consuming any CPU. Still, you are increasing the more instance, right? So instead of that, in the microservice, when your one microservice is under load, it will scale itself. Okay, you do not have to worry about another two microservices. If they are not under the load, they will be remain same instances in the ecosystem. And if your pay scale microservice remain heavy load, it will scale up with 1 2 3 4 5 instances, whatever you can configure based on the CPU and memory. And once the load has been decreased after fifth date, it will automatically come down with the normal instances. So you can take this advantage, granular scaling, for the individual microservices. Mm, these are the best practices which is used nowadays to implement the microservice. So separate data store for each microservices. As I told, design your microservice based on the domain. So your database would be separate for that microservice only. You do not have to worry about the shared data between one schema shared between two microservices. Then keep code at a similar level maturity. So code would be at the similar level, like whatever code maturity parameters you can define, you can implement for that microservices only. Then separate build for each microservices. Each microservice have their own CI/CD pipelines. So you can trigger, and whenever you want, you can trigger a pipeline. You can start build, you can deploy the microservices. It will not impact another one. Okay, so you do not have to worry about that. Then deploy into containers. As I told, when we are talking about the microservices, containers is the most important part, and in the microservices. So each microservice will be deployed on containers. Okay, so when we have 100 containers with different microservices in the single instance, you do not have to worry about that, because each containers have their own execution area. It will not impact another microservice. then treats servers as a stateless. So all the servers become a stateless servers. So you can communicate via microservice. You do not have to create any session. So storage and session sticking, and there is a multiple problems. Session hacking would be not available over here. So all the servers are stateless servers. There is no state management for the microservice. You can do everything via the token. Okay. Okay, so about this was about the concept of microservice. Now when we are working with the microservices, you may heard like Docker. So Docker is the infrastructure where we are deploying our microservices. And you may heard another word like Kubernetes. So Kubernetes, it's a cluster management which is designed by Google. Okay, and Kubernetes is used to design your cluster, and the containers are runs inside the Kubernetes. So Kubernetes provide you the management console. Basically using that you can communicate with your clusters, you Docker containers. So Docker containers is nothing but one Linux instance, you can say, with small scale configurations. You have a big instance which have a 18 GB RAM or 16 GB RAM with 200 TB, 100 TB hard disk or 1 TB hard disk, whatever, with 8 core CPU, 64 core CPU. But containers, it's like a small instance which has a 2 GB RAM and 1 core CPU, 4 GB RAM and 2 core CPU, whatever you can configure. Okay, so in the technology things, when we are working with the microservice, we have a different ways. Like we can design the microservice. We have a Eclipse micro profiler. Using that, you can design your microservices. Then we have a Spring Boot. Using the Spring Boot, you can design your microservices. And you have a Node, you have a .NET, you have a Python. There are multiple technologies you can use to design your microservices. Then if we talk about the Spring Boot component, which are very important when you are designing your microservices. So first is a Zul proxy. So as I told, Zul proxy is an API gateway. It is acting as an API gateway while designing the microservice architecture. It is responsible to manage routing, central authentication, login, and auditing, and etc. So manage routing means all the requests first comes to the Zul proxy, and Zul proxy itself a Spring Boot component. So you can integrate your authentication in the Zul proxy component, or you can exclude that to the separate authentication module. But in the Zul proxy, when you integrate it, you can use the same component to authenticate the user, as well as you can use the caching for the better performance for token storage and all. As we have seen in the last tech talk, spring caching is the most important to enable you to store and improve the performance. Then Spring Eureka act as a registry. So all the microservices will be registered at Eureka for service discovery. So whenever we are coming up with a microservices, it has allocated one dynamic IP and one dynamic port. Okay, so every time it is a different. So you cannot directly hit the microservice using the IP and port. So Eureka is the module in the Spring Boot which is used to register when microservices come up. It registers itself via name with that IP and port. So in the Eureka, you will just discover that microservice by name, and you can hit the APIs by name only. So HTTP, then name, and then slash your API details, and so on. So it will directly read out to your microservice. And if it is a more than one microservice, it will automatically balance by the load balancer. Then another one is a sleuth and zipkins. So when we are talking about microservice, there is a most important part, communications. So for example, let me give you one scenario. We have bank applications, and I'm doing withdrawal. Okay, so in the withdrawal, it will go first to check my balance. Second, it will go to authenticate myself. Like it is at first it going to authenticate myself, then going to check the balances, then going to withdraw, then deduct the balances, send a message, and so on. Okay, so over here what happened, when something goes wrong in the middle of this sequence, you are not familiar, like you are not able to identify like, hey, what's going on, why this it's failing and where it is failing. Okay, so sleuth in Zipkins is providing a tracing the request. So whenever you make a request to the API gateway, and the first component sleuth and Zipkin, it will allocate one trace ID, and that trace ID will be used to all your communication from one microservice to Z microservices, and back that trace ID to the user as a response. So you can use that trace ID and you can check the logs in the Splunk or in the Kibana, whatever the log management system you have configured via that trace ID. So you can get actual idea like, hey, where it got failed. Okay, and you can work on that. Then another is the Spring Data. So Spring Data empower you to use the communication your microservice with the database without making any huge differences. So in the monolithic, in the previous one, maybe you have seen like you have to write down too much boilerplate codes and connections, and if you use the Hibernate, then you have to write down the named queries and many things, which is removed completely from the Spring Data. In the Spring Data, you have to just implement your repository and you can write down the simple method name. It will automatically convert to the queries. So for example, you have one table employee and you want to find all the records like employee by name and age. So whenever you design your method, you have to just write down the method name like fetch all by name and age. So based on the method name, it will automatically convert your query in the database execution statement, and you will get all the data back from the employee table. So this is a Spring Boot data module which is very powerful to communicate with database. Then Spring Caching, as we have seen in the last tech talk, it is used to cache your data, okay, to improve the performance basically. So whenever we are working with the large ecosystem, and uh, we have to think about the cost and all. For example, uh, we have a we have a one ecosystem which is using some DynamoDB things. Okay, so DynamoDB is costing based on the operations. So for each and every query, I cannot go to DynamoDB and say, hey, provide me this data, because when I am making the query, it will cost me. So to reduce the cost, we can introduce the caching in middle of the communication with database and application. We can introduce the caching, we can reduce the cost, and we can improve the performance, because it will remove your network call to communicate with DynamoDB, prepare your data and back to the applications. Then Spring Actuator. So Spring Actuator is the very important module when we are designing the microservice architectures, because uh, in the Spring Actuator you can see like it's actually monitor your applications. So it will empower you to monitor your applications at the high level. For example, you have to take the memory dump, you have to see the log level, you want to change your log level in production. In the production you always have an info log level or error log level, but to trace something you need to change to debug. Then Actuator will help you to change that log level runtime. Then you can take a memory dump, thread dump using the Actuator. Then Spring AOP, it's a core module. It is used everywhere to writing the hooks. Whenever you want to do something between the flow, you can use the Spring AOP. And Spring itself use Spring AOP as a too much in transaction management and all. You can see in detail. And Spring scheduling, so used to configure your related repeated task execution based on the cron or interval. So you can enable skills Spring scheduling, and you can configure like this task would be execute every 1 hour or 2 hour or 3 hours, whatever you can configure. Thank you. So these are the points which I covered in the microservice informations. Yeah, anyone have anything to ask?
Yeah, hi Uday.
Yeah, hi.
Let's take example. You have four microservices,
Mhm.
A, B, C, D, and if B is somehow down
Okay.
or not able to connect, and
Mhm.
C and D is also like let's take example. It is also depend on B.
Okay.
Okay. So how it is going to be work? It is going to be auto restart, or it is going to be take some retries.
Okay. So, good question. Sorry, I forgot to cover this point. So, whenever we are talking about microservices, so when we are communicating via REST, so as I told you, it's a blocking IO, right? So, for example, A is communicating with B, C, and D, and C is down. C is not responding. Either any problem happened, we don't aware about that. So, over there, you can use the hystrix. So, hystrix is called a circuit breaker. So, you can implement the hystrix, and in the hystrix you can implement the default response whenever the service is not responding, so you do not have to wait until you get the request timeout. If it is failed first time, it will register in the hystrix, and it's a hystrix responsibilities, and you can configure hystrix command based on the time you can provide, so it is their responsibility to revert back to the customer until the service comes up. Okay, so this is, we have a Spring Boot. Another, we have external components like console service. You may search in the Google. Console service is also used to manage such kind of things because it provides this also functionality in one box. Console service.
Okay, got it. Thank you.
Hi, can
Hi
we put
Uday,
up the quiz
Parthiv.
link as well?
Uh, Hi Uday, Parthiv here. So it is
Yeah,
a
hi.
very good session. Thank you so much for that. I just want to add my 2 cents over here. Uh, I have heard about means I am using the Quarkus and the Micronaut, which are also the microservice Java framework, which is designed only for the microservices and backed by the Red Hat. So it is a very interesting thing if someone can look into Quarkus, Quarkus.
Workers.
Yeah,
Okay, I'll look into that, and I'll try to cover that thing in next tech talk whenever I have.
yeah, it will be very good. Yeah. Thank you.
Sure. Thank you. Thanks for info.
Yeah, Uday, one more question. If we using a microservice, so if we use a SAID database or the different database for each microservice, so which will be the good idea to take as
Okay.
in a microservices?
Okay, so when we are working with the microservices and when we are working with a shared database, okay. So in the shared database, what happen? You have to take care about the transaction management, okay, because in the shared database, you are not know like when the transaction going to fail, in which microservice you have be a problem, right? So you have to perform implement two-phase commit. So one is the orchestrator and another is the consumer like actual microservice. So once the all microservice commit, then orchestrator commit itself, then and then the transaction has been completed. Otherwise, your data would be in the inconsistent state. So when we are using the shared database, you have to implement that two-phase commit. Or in that what happens when your one microservice is not responding, you have to wait until you get a timeout. So this is a problem in two-phase commit. So majorly when designing the microservice, try to avoid this shared database. Create your own schema which is communicative or database only. And if you want to share your schema data to another microservice and you don't want to expose the endpoints, then you can provide the materialized view. And using the materialized view, it will refresh every time, and that view you can provide the grant to that another schema, so they can make a query to your schema directly using that materialized view.
Yeah, thank you. Thank you.
Okay, anyone, anything? Actually, I took 10 minutes more.
Uday, while people have, if they have any questions, I would request them to add it in the chat box. Meanwhile, we can just put up the quiz link for people to attend the quiz as well.
Okay, so okay, I am stopping my sharing.